Welcome. You should be on page 25 of your Algebra 1, Quarter 2 notebook. In this video, we're going to talk about solving systems of equations using substitution. Now remember, a system of equations is two or more linear equations on a coordinate plane, and the solution to that system is where those lines intersect. And we can use a graph, certainly, and find out where the lines intersect, and voila, there is the solution. But you can also find your solution without graphing and follow an algebraic process. There are two different ways. In this video, we're going to talk about one of them, and that is called substitution. So there are 3 steps to follow when using substitution to find the solution of a system of equations. First step is, if necessary, and that's key, sometimes it's not going to be necessary, you need to rewrite one of the equations so either the x is y is or y is isolated. You need one of the variables to be all by itself. Your next step is you're going to substitute the expression from step 1. So if x equals 3 plus y, you're going to substitute 3 plus y into the remaining equation, and your goal is to have a new equation with one variable, and you solve for that variable. Finally, you plug the value you just found back into one of the equations, and you find the value of the second variable. Well, that is a lot of words, so we need to see what that looks like. But before we do that, you should remember that your answer should have an x and y value, because the solution to a system of equations is a point, an x and a y. One, just the x or just the y, not enough. So we're going to do these 4 examples in this video. Let's take a look. When I look at number 1, I have, looking at step 1, do I need to isolate x or y? Well, actually, in this situation, y is by itself in both equations. So this tells me y equals 2x minus 6, but y also equals negative 1/4 x plus 3. You know, y and y are the same thing. So if they both equal 2 different things, these 2 expressions are also equal. So I can write a new equation that states 2x minus 6 equals negative 1/4 x plus 3. Both of these expressions are equal to y, so they are equal to each other. And now I have an equation I can solve because there's only one variable x. So I need to follow that process of solving multi-step equations. Do I have any distributing? No. Do I have like terms to combine on this side? Nope. Like terms on this side? Nope. Are my variables on the same side? No. I do need to move 1/4 x over here so they can be combined. So I have 2 and 1/4 x minus 6 equals 3. And now I've got myself a 2-step equation. I need to get rid of that addition and subtraction or the constant first. So I'm going to add 6 to both sides. And I know 3 plus 6 equals 9. But as I bring this particular mixed number down, I'm going to turn it into an improper fraction. 4 times 2 is 8, plus 1 is 9. Keep the same denominator. And now I have a fraction I can work with in this solving process. I have a fraction coefficient, and we know that I multiply by reciprocals to remove the fraction coefficient, because a number multiplied by its reciprocal always equals 1. So x equals 9 over 1 times 4 over 9. I can cross simplify the 9's, and I will get 1 times 4 over 1 times 1. But if you don't see that, just remember, multiply straight across. I get 9 times 4, which is 36, 1 times 9, which is 9, and 36 divided by 9 is 4. So I've done step 1, which I didn't have to do anything. I did step 2. I got my equation. I solved for one of the variables, and now it's time for step 3. I'm going to take x equals 4, and I'm going to substitute it into one of these 2 equations to find my value of y. I'm going to use y equals 2x minus 6. Please note, you can use either equation. You will come up with the same value of y. Y equals 2 times 4 minus 6. Y equals 8 minus 6, y equals 2. So I have a value of y equals 2, x equals 4. If I want to write it as an ordered pair, you can see that I have all of the pieces for a solution to this system of equations. No graphing necessary. Let's take a look at number 2. Number 2, again, I'm looking to see if I have to rewrite one of the equations, and in this case, I do not. X equals 12y minus 1. So the x is isolated. Sadly, this isn't an x equals equation, or I could follow this process, set those two expressions equal. Instead, I need to substitute this expression, x equals 12 minus 1, so I'm going to substitute right there into the x. So that is 4 times x, so 4 times 12y minus 1 plus 10y equals 25. I have an equation that I can solve. Do I have some distributing to do? I do. I have 4 times 12, which is 48y. 4 times 1 minus 4 plus 10y equals 25. No like terms over here, but I do have 48y plus 10y. So I have 58y minus 4 equals 25. All my variables are on the same side. In fact, I've got my two-step equation. I'm going to get rid of this 4 first. And I now have 58y equals 25 plus 4, which is 29. I'm going to divide both sides by 58. And I get y equals 29 over 58. I do want to see if I can simplify this. Well, believe it or not, 29 divided by 29 is 1, and 58 by 29 is 2. So y equals 1/2. Now, time to find x. I'm going to use this equation. X equals 12y minus 1. I will substitute the value I just found. 12 times 1/2 minus 1. If I put that over 1, I get x equals 12 times 1 over 1 times 2, which is 12 over 2. That equals 6. Sorry, I got a little excited about the answer. 6 minus 1, x equals 5. So here's my solution. X is going to equal 5. Y will equal 1/2. I have a point at 5, 1/2 as the solution to this system of equations. These two lines intersect at that point. These two lines intersect at that point. Let's take a look at number 3. I can see I finally have to do step 1. I need to isolate one of my variables. It does not matter which variable you isolate. These two lines are always going to intersect at the same point. So I'll just subtract y. So I have x equals 5 minus y. So I am going to substitute this expression, 5 minus y, in for the x in that equation. So I have 3 times 5 minus y plus 2y equals 13. Do I have any distributing? Indeed I do. 3 times 5 is 15 minus 3 times y minus 3y plus 2y equals 13. No like terms over here, but I do have minus 3y plus 2y minus 3 plus 2 is negative 1y equals 13. I've got myself a two-step equation. I'm going to subtract 15 from both sides. Negative 1y will equal negative 2 because 13 minus 15 is negative 2. I'm going to divide both sides by negative 1 and y equals 2. Last step, I'm going to take y equals 2 and I'm going to substitute it into an equation. Please know you can use either equation and get the same answer, but I'm going to use this one. X plus 2 equals 5 minus 2 minus 2. X equals 3. So I've got my two values, my x and y value. Of course, this should be y equals 2. Excuse me. And my point where these two lines intersect will be at 3, 2. final question in this video, we're going to take a look at number 4. One of my equations already has y isolated, so I can start right off by substituting this expression in for y. So I have 3x plus 2 times negative 2x plus 9 equals 18. Let's do my distributing. I have 3x. I have 2 times negative 2x. That's minus 4x. 2 times 9 is plus 18 equals 18. I've got some like terms to combine here. 3 minus 4 is negative 1x plus 18 equals 18. I do have a one-step equation, so I'm going to subtract 18 from both sides. And I have negative 1x equals 0. And of course, 0 divided by any number is 0. So in this case, the value of x is 0. And I'm going to use my first equation, y equals negative 2x plus 9. So y equals negative 2 times 0 plus 9. Y equals 0 plus 9. Y equals 9. So y equals 9, x equals 0. These two lines will intersect at the point 0, 9. And that's all for this video. Thanks so much, and goodbye.